Okay, so we're at part 183. Welcome back. It's been a while. I've been writing some novels and a screenplay for April 2012. And now I'm getting back to the research that I started back in January of 2012. And I'm going to be filming 18A all the way up to 18Z. And then posting them in the next couple of weeks. Okay? Most of them are just data. I haven't done a lot of formulas with them. There are some formulas, but a lot of them are just basically data and research of information that came up. I'm going to breeze through them as quickly as possible, and then I'll probably go back over them when I have more time. I just want to get the videos up so that you guys can look at the research information and see what you can do with it. Okay, so this one's line 18A 4A, NASA Safety Valves Propulsion Ariane Titan 4 Wow Seti. Okay, and there's the Wow Seti alien radio signal. And what happens is when we Google the keywords from this number, different things come up, and this is my research about it. Okay, so I Googled the NASA experimental data analysis of high pressure safety valves prototype stage, which is what came up. So then I Googled the words to see what comes up, and we got a PDF file here from Safety Standard for Oxygen from NASA headquarters. It's a C7 designs illustrating rotating stem valve and particle generation configurations. Talks about the prototype, liquid high pressure oxygen, and its analysis of fragmentation data for liquid propellant vessels. Okay, so there's another PDF file, propulsion controls and diagnostic research in support of NASA. Again, this is technical data about pressure and propulsion. Then we have the CFD modeling of globe valves for oxygen application. This came up from eSpace Library. And this is the experimental results were validated by a CFD analysis. And it's a high pressure flow of gaseous. It's about the Aeronautics and Space Administration from NASA as well. The next thing that came up was minimizing pressure relief valve seat leakage. It's a PDF file from CFINE. It's dspace.mit.edu, and it's a mathematical model that's been developed to stimulate pressure relief valves. And again, there's more data there to look at. The next thing will be NASA Software Safety Guidebook. That came up. And then there's the rocket. We did the rocket from Wikipedia. Talks about rockets, pressures, and experimental results. We have flow on plate motion and compressor valves. Next is centrifugal compressor surge modeling identification for control. And then there's the aerothermal paper session abstracts from NASA. That's post-flight analysis of High Fire 1. Then you got the NASA Scientific and Technical Aerospace Reports, 20th and 21st century. They're talking about the assessment of NASA's Glen Aeroacoustic experimental and predictive capabilities for installing cooling fans. The next thing that came up was SPL Swiss Propulsion Laboratory. Again, more stuff about NASA. The next one is influence of high pressure hydrogen environmental or tensile. Then there's Sierra Lobos and NASA's Langley operations, and talks about more data there. So April 26, 2012, my thoughts. All the data points to issues with valves, safety, leaks, and then patents, theories, and inventions on how to fix the problems. This section will mostly be just data. So here's a picture here of the Ariane 5 that came up as well. And this is the Titan 4. It's another type of rocket propulsion thing that they've got. And it's from astronautics.com. Nitrogen tetroxide N204 came up. Titanium, dinitrogen tetroxide, quotes from Wikipedia, is a hypergolic propellant often used in combination with the hydrazine-based rocket fuel. Cool nitrogen tetroxide is compressed and heated, causing it to dissociate into nitrogen dioxide at half the molecular weight. This hot nitrogen dioxide is expanded through a turbine, cooling it and then lowering the pressure, and then cooled further in a heat sink, causing it to recombine into nitrogen tetroxide at the original molecular weight. It is then much easier to compress to start the entire cycle again. Such dissociative gas Brayton cycles have the potential to considerably increase efficiencies of power conversion equipment. A thermodynamic preference for the nitrate ion to bond covalently with such metals rather than form an ionic structure. Such compounds must be prepared in anhydrous conditions, since the nitrate ion is a much weaker ligand in water, and if water is present, the simple hydrated nitrate will form. So the next thing we Google is urothiol tetranitrogen tetroxide, and this comes up. www.infochima.de. So Google shielding gas nuclear fusion comes up. The possibility of producing plasma regions at thermonuclear fusion. That's iopscience.iop.org. And this is walls by means of magnetized high pressure gas. And nuclear fusion is and then that's mentioned. And then that's it for that one. These are the tags that you're going to find in this video here. Okay, and that's the end of that video. We'll go on to the next one now.